Hi everyone, thank you for watching this if you watched the last one, because the response I got was really nice. And yeah, this one is going to be on fuel cells, which is in C6, continuing with the C6 theme. Of course, the big news is that I think I've solved the image movement problem. Turned out I had my electronic image stabilization on, and that wasn't great. Okay, so we've got to start with the reaction between hydrogen and oxygen, which is obviously absolutely riveting. I'm presuming you're aware that the symbol for water is H2O, therefore the word equation for its formation is hydrogen plus oxygen turns into water, and the symbol equation is 2H2O, so 2 hydrogen, plus oxygen, O2, turns into 2H2O, so 2 water. Of course, the reason they are O2 is because they are diatomic, which is of course a word that you will see once I realise that I didn't write it right. So yes, that means that it's 2 atoms together, and that's how they like to be. You also have to know that the reaction is exothermic, which means that energy is being given out, which you can probably remember by the fact that it's exo, which means exiting, maybe, that might work. You also have to know about the energy diagram, which is basically just describing a trend. And this is the shape of the one for the reaction between hydrogen and oxygen to form water. It starts off at the middle at 2H2 plus O2, it then rises where it is 4H plus 2O, and then it falls again once the 2H2O has been formed. This is the reaction that happens in a fuel cell. The definition of a fuel cell is quite long. It's that a cell supplied with fuel and oxygen that uses the energy produced by the reaction between the fuel and oxygen to generate electrical energy efficiently. The fuel is hydrogen, as you might have guessed from the fact that we had to look at the reaction between hydrogen and oxygen. So summed up, a fuel cell is a thing which uses the exothermic reaction between hydrogen and oxygen, something we looked at earlier, to generate electrical energy. The efficiency of this is something we will be coming back to, and really it's not that hard, it's basically just a bit of factual recall. So what happens at each electrode, because a fuel cell has electrodes? At the anode, this is something we learned about previously in electrolysis in the previous video, it might be worth revisiting that if you can't remember what an anode is. The reaction is H2 plus 2H plus 2E minus, which basically means that you are breaking down a hydrogen. I think of this as that a fuel cell in this way is in acidic conditions, so it's breaking stuff down and it's breaking H2 into its component parts. You can write this as H2 minus 2E minus turns into 2H plus, and this shows quite nicely that its oxidation is happening because the hydrogen is losing electrons, and that's what oxidation is, it's losing electrons. At the cathode, the equation is O2, oxygen, plus 4H plus, 4 hydrogen ions, plus 4E minus, 4 electrons, to form 2H2O, which is water. The adding of the electrons shows that it is reduction that is happening in this, because reduction is gaining electrons. It's counterintuitive. So the stages in a fuel cell are that at the anode, each hydrogen atom loses an electron, and the second stage is that the hydrogen ions are attracted to the cathode, where they combine with electrons and oxygen to form water. You can basically just figure this out by remembering the equations and just describing what's going on. Unfortunately, you also have to know about the equations in alkaline conditions. At the anode, it's H2 hydrogen plus 2OH minus hydroxide ions turns into 2H2O plus 2E minus. The fact that the electrons are on the product side of the reaction shows that they are no longer in the reaction, so have been lost, therefore showing that it is oxidation, because as before, oxidation is loss of electrons. At the cathode, the equation is O2 plus 2H2O plus 4E minus turns into 4OH minus. The way that you can probably remember that it's OH minus that's formed is that it's in alkaline conditions, and alkalis have OH minus ions in them. Also, the fact that it is plus 4E minus shows that it is reduction, because reduction is gain of electrons. But what are the advantages of fuel cells? Well, you basically just got to think about the ultimate utopian method of electricity generation. The advantages are currently coming up on your screen very quickly thanks to Speed Editor, and this is where the efficiency thing came in from earlier. It's basically just remembering that it is an efficient reaction. Are there any uses? Well, yeah, they can be used in space for various reasons. It produces water for the astronauts, as we saw previously, which is safe to drink, there are no pollutants in it. It's also lightweight, and they're also very compact. There are also no moving parts, hence the statue of a zebra. It can also be used in cars. And the reason that a lot of car manufacturers are looking into fuel cells as a potential method for fuel generation is because of CO2 emissions. Because when we burn fossil fuels, which is the energy source for cars, it releases a lot of CO2, which has been linked to climate change. with fuel cells, this isn't an issue, which is of course wonderful, because it means that then the people that produce the cars can go on producing more cars and making lots of money without wrecking the environment. Also, the fuel source for cars is decreasing, which means of course that they are non-renewable. However, we have a potentially massive source of hydrogen in the form of electrolysis of water, which means that it is renewable, so people making cars can continue to make cars, which is great for them. However, there are of course disadvantages, as there are to everything. The first one is that in a fuel cell there is a poisonous catalyst, which has to be disposed of at the end of the working life of the fuel cell, which can produce air pollution. Also, getting the hydrogen and the oxygen required may require using energy produced by fossil fuels, so it might not be entirely renewable. Thanks for watching, hope this has helped people. My current list of stuff that people want me to do videos on is C5, meiosis and mitosis, and P3, just going back over some of the equations and stuff. I am willing to do videos on any of the stuff from these subjects. I mean, I could attempt other ones, but I haven't actually been taught them, so it'd be pretty bad.